This tutorial shows you how to acquire Ebsd maps in Aztec. We're in the Ebsd application and the map navigator. Just click on Specimen 1, then right-mouse click and then we can rename. We can add project notes and also specimen notes, and you can copy and paste into here. Moving towards the bottom of the screen, which is where we're going to add phases, we'll also see from the status bar that the stage is already tilted at 70 degrees, ready for Ebsd. So let's add phases. We can type in the phase that we're interested in. In this case, we're just looking at a nickel sample, so it's only one phase. So add the phase for acquisition. And we'll see the nickel superalloy phase being added, and we'll see the unit cell on the right. Phase details are in the bottom right hand of the screen. And if we right-mouse click on the phase view, we can show reflectors. And by clicking on reflectors in the list, we can see them highlighted. We can also just move around the diagram and see each highlighted reflector will be identified as to which reflector it is. By default, we get a particular number of reflectors. By default, we should probably just leave those as they are. So moving to the mini view on the right, we can see that our signal strength from the Ebsd camera is very low and the noise level's high. And that's because the camera is retracted, so in the status bar, looking for the control of the Ebsd camera, we'll narrow the camera in. And as the camera moves in, we see the noise reduces and the signal strength increases. Now let's look at the tab for specimen geometry. We don't need to use a pre-tilted specimen hold because we've got the stage tilted, and here we've got the specimen orientation with our rolling normal direction. So moving to Scan Image, we can now acquire images. In this case, we're looking to acquire 2 images from the secondary and the forward scattered detector. And we'll go for a continuous scan, so as we acquire, we can modify brightness and contrast. So we're seeing 2 images acquired simultaneously. Not all SEMs are able to do this, but in this case we can. So we're just adjusting the signal level on the secondary electron image, and now on the forward scattered image, and you can see how much more contrast we get in the forward scattered image, that crystallographic contrast. Back into image settings, and we'll just go for a longer dwell time, turn off the continuous scan, and just do a single frame now with a longer dwell time to reduce noise. And see on the mini view, that's now changed to be the ED characteristics of the rate meter, so we'll just swap that back to be our Ebsd characteristics. And we can see the high signal strength. Moving on now to the Optimize Pattern step, we can see the electron image and the electron backscattered patterns with and without processing. Let's just change the electron image that we see to forward scatter because that's easy to see the grains in this sample. And we can now just click on any of the regions there and see the live and the processed pattern. Moving to the camera settings, let's have a look at the binning mode. If we go to a smaller binning mode, then we'll see that the exposure time is much longer. So typically for maps, we need a high level of binning, which gives us then a quick acquisition of pattern. And typically we're also going to use high gain. So clicking on Auto will auto-level the brightness and contrast in the patterns. Typically we use auto background, but if you've got any problems with marks on the phosphor, then you can also add a static background. So here we're collecting a static background. And we can add that into the processing. Now when we go back and click on a point in the image, we'll get the pattern from that point. And what we should do is just go to a few points and just check that we get a good pattern on each of these grains. So we'll just click off there, and now we'll go into the next step, optimize the solver. Here we can just adjust the sizes of the quadrants in the display. And we'll just begin and click on points in the image. We'll see the pattern and also the solution. So looking at the processed pattern, right mouse click, we can choose to display bands and also the solution simulation. We can see here we have a good fit. And in the bottom left we can see then the unit cell for that solution, showing highlighted reflectors, and again right mouse click we can choose which of the reflectors we display. So let's just try some different regions and we can see bands and solutions. If necessary, we can refine the solution because we want to keep the MAD level low, and we can see a refinement has improved it slightly. We can also see the huff space window that's used for the solution, and we'll see we've chosen 7 bands here, and we can see the 7 spots relating to the 7 bands. So now we're set, we can start acquiring the maps. So the tools within here will allow us to acquire a map from a particular region, so we can set the width of that region in microns, and for the moment we can't set the step size because that's locked. But if we lock the area width, now we can set the step size. Alternatively, there are other tools, so here we're actually going to acquire the map from the whole region. So let's just check the settings. We can decide the resolution and the step size, and also set up the ED acquisition conditions. And here we're going to acquire the ED as well. Start the acquisition. And here we have the X-ray maps and the Ebsd maps being acquired simultaneously. Adjusting the display changes the sizes of those images in the display. The maps continue to acquire, and we can move to the Construct Map step while the maps are acquiring. Within this step, we can look at the data values from anywhere in the map, so we can see the phase and the orientation as we hover the mouse around the map. And we can also show the orientation information from any position, so just by clicking in the map we can see the pattern, and also the orientation. Right mouse click will enable us to display reflectors if we want to. Going back to Acquire Map, the map's still being acquired, and we could, if we wanted, set up additional maps with these tools. We can also choose which of the Ebsd maps are displayed in the layer image, so they can be a single orientation map or a mixture of orientation maps. Here we've set up an additional map using map data 2. If we don't want to proceed with that, we can edit it out. So, moving to the data view, we need to switch to the current site. Map data 1 still being acquired, map data 2 is queued, and we can choose to cancel it. We can change the view that we see in this step to be just the layered image and the maps, or just the maps. So the maps are now complete, so all we need to do is move the camera out to a safe position and also to save the data. It will have been auto-saved, but let's just save the project. And that's Ebsd mapping complete.